Hello students and the warm welcome in this 13th lecture of the thermodynamics. So students, first of all we will revise some part so you will get it very easily again, so you will be able to keep this in your mind for the long time till the exam. So students, the part we have learned in the previous lecture is the isobaric process, in which you can see the first of all the PV diagram of the isobaric process. The graph of the PV of the isobaric process has been popping in your screen, so you can see there. So you will be able to see that the pressure is indicated on the y-axis while the volume is indicated on the x-axis. So as far as the graph is concerned, the point A has been changing into the state to the B, means point A will be existing at the first state, while the point B will be at the point where the final state will be there of this isobaric process. So during this process you can see that the pressure is the constant while the change in volume is only occurred there, as you can see directed by the PV diagram of the isobaric process. So we will see now the isobaric is the thermodynamic process in which the pressure will be constant, means the entire process of the changing the state from the initial to final will be conducted. Thus the delta U, Q and the W will not equal to 0, means as the pressure will be zero, pressure, let it be pressure constant, but the change in volume is there, means definite amount of change in volume will be there. Thus we can say the change in volume will give rise to the work done. Some amount of work done will be definitely there in this isobaric process. Thus thermodynamic of isobaric process is nothing but the delta P will be 0 as the pressure is constant for the isobaric process. So there will be the expansion at the constant pressure, means the pressure will be constant, thus there will be the expansion for this condition. Now let VITI and the VF and the TF are the variables of the initial volume and the initial temperature, and the final volume and the final temperature. Now the work done in this expansion, the work done in this isobaric process will be given as W will be equal to PdV. As you can see on your screen, the W is equal to PdV, means at the constant pressure there is some increase in amount of volume, or the decrease in amount of volume you can see. So PdV may be further written as the P into Vf minus Vi, means there is the change in volume, and after that the P may be written as Nr, means as you can see from the ideal equation of gas. So you can see that the PV is equal to nRT is the ideal gas equation. So from that we have written the value of PV is equal to nRT, and the T we have represented in the form of TF minus TI. Now the next stage is the change in internal energy is given by delta U is equal to NCV delta T. We can represent it as NCV delta T. So now NCV delta T may be written as TF minus TI, while the CV is nothing but the specific heat constant. Now according to first law of thermodynamics, as we know that the Q is equal to delta U plus W, so the value of delta U is nothing but the NCV TF minus TI is the value of delta U, plus the value of W is NR TF minus TI. So these are the two equations. We having the two values of the delta U and the W. So we have put in the first law of thermodynamic equation. So we'll be taking the NCV and the NR in common, and the TF minus TI will be the common term. Now NCP means NCV plus NR will be termed as NCP, and the TF minus TI will be the remaining term. So the Cp is nothing but the specific heat constant. So the temperature of the system changes in isobaric process with the delta U, means with respect to the internal energy changes. So there will be the Cv plus R, it will be nothing but the Cv plus R. So R is nothing but the gas constant, and the Cv we know that the specific heat constant, we have already learned about that. So now students, we will be further looking for the next part of the lecture. So students, next part in this lecture we are going to see is the adiabatic process, which is the process number 5. Now you can see the PV diagram of this adiabatic process, a process in which the no heat transfer from the system to environment will be there, or the environment into the system. Thus the Q means the amount of energy which will be transferring between the environment and the system will be equal to 0. Now the heat transfer can be prevented by the insulating the system of quick change to avoid exchange of heat. Means we are taking here the quick change, so there will not be any transfer of heat. Thus the system is totally insulated with the insulated material. That's why the heat transfer between the environment and the system will not be there. Thus the heat, that is the internal energy delta U, it will be equal to minus W. Now students, you may have the question that why their work done is minus. So as you can see, the system is totally insulated by the insulating material. We have already discussed about that. So as the system is insulated, so there will not be any further movement of the piston outward or the inward. That's why the work done, total internal energy will be equal to the work done which has not happened. Means that work done will not be there. That's why it will be in negative. So the total internal energy will be conserved there inside the system as the no heat transfer and no work done and the no further movement of piston. That's why the negative sign for the work done has been given there. Now the work done W is negative because system is compressed adiabatically. So this is the reason that the minus sign of the W, and the reason in detail I have explained already. Because of insulation, no further movement of piston, and the total internal energy has been utilized and the not work has been done there. So this is the one of the reason of minus sign of the W, and the system is compressed adiabatically. Now thermodynamic of adiabatic process, we are going to see PV raised to gamma will be constant, that is C. Now that gamma which is raised to the power V, we can further represent it as the Cp minus Cv. So what is mean by gamma which is raised to the power of the V? The gamma is nothing but the adiabatic ratio, which is the 5/3 for monoatomic gases. 5/3 monoatomic gases. Now students, you may be having a question in your mind that what mean by the monoatomic gas. The monoatomic gases means the gases which contains the only single atom will be termed as the monoatomic gases, and the adiabatic ratio for that gases is 5/3. Now this value of adiabatic ratio for the diatomic gases is 7/3, and you can also term it as a Y minus 7/3 will be the overall value. And further for the polyatomic means, first of all I will discuss the diatomic gases, mean the gases which contains the only two atoms there in that gases, then we can say it is the diatomic gas. Now the polyatomic means, poly means more than 2 atoms will be there in the gas, so then it will be termed as the polyatomic gases. And the value of adiabatic ratio Y for it is nothing but the 7/5, and for the polyatomic gases it is the value of adiabatic ratio 4/3, which has been turned from the 8/6. So this is nothing but the entire adiabatic process we will learn. Now the next part of this process we will see now. So the next part of the calculation of the adiabatic process is popping in your screen now students. You can see in adiabatic process or in adiabatic system is isolates, means the system, entire system has been isolated with the insulating material, hence the no heat transfer will be there. There's no exchange of heat, hence the delta T and the delta U both change Okay, so we can see the as the system is insulated or the isolates, so the delta T and the delta U both will change. Okay, so the change in internal energy, that is delta V, will be equal to CV delta T. Now you know the what mean by the CV. CV is the specific heat constant. Now we will see what will be the amount of work done during this process. So the work done will be the integration of P dV from the limit of Vi to Vf. So we will simply put the value of V. We will get then C out of the integration part. There will be C, and in the integration there will be the V raised to gamma dV upon V raised to gamma from the limit of Vi to Vf. And as we know that the PV raised to gamma, which is called, thus it will term as C into bracket V raised to C minus gamma plus 1 upon 1 minus gamma. So V, thus the V changes from the Vi to Vf, so the C upon 1 minus gamma into bracket 1 upon Vf into bracket gamma minus 1 upon Vi into bracket gamma minus 1. This will be the Vi and Vf will be get multiplied into the bracket, but we know that the PV raised to gamma is constant and the Pi Vi raised to gamma will be equal to Pf Vf raised to gamma. So this equation we can use into this equation. Equation we can use into for the calculation. We will get the work done will be 1 upon 1 minus gamma into bracket Pf into V raised to gamma Vf raised to gamma upon Vf raised to gamma minus 1 minus Pi into Vi raised to gamma upon Vi raised to gamma minus 1. So this will be the entire work done for the process of adiabatic we have learned. So student, this is the question which has been asked most of the time in the exam. So you have to get ready with the PV diagram, explanation, and the derivation of this adiabatic process. So you have to just revise for many times, so you will get it very easily to write the answer in the exam. So after that student, we have learned the cyclic process, which is the 6th number of process. Now we will take a quick review over that. So this is also one of the important process which you can get asked into the exam. Now we will take the quick review now. First of all, we will see the points. The thermodynamic process that returns a system to its initial state in the cyclic process. That is, you can see that we will discuss the PV diagram, but before that, initial and final state is same, that is delta U will be 0. So you can see the PV diagram of the cyclic process students. You can see at this point the volume is initial volume, which is the constant, which has remains constant, and after that the value of pressure has been decreasing, it is increasing from the Pi to Pf. The value is increasing from Pi to Pf. Thus, as the value of pressure goes on decreasing and the value of volume goes on increasing, you can see in the graph. As the point A is moving to the point B, means point A will be changing its state at point B while it following the path 1. Now one more path it is following, that the point B will again come to the point A, means the state at which the point A was initially present, the same state will be there after the returning the point A from the B. So path following for that will be path number 2. So this is nothing but the cyclic process student. So in this process, the thermodynamic process has been followed and it has been returned into its initial process by the another path. So this is the cyclic process. Now the free expansion, this expansion or adiabatic expansion, there is no exchange of heat, all environment. So there will not be any exchange of heat. So the Q will be, W will be 0. And according to the first law of thermodynamics, the delta U will be equal to 0. And for example, the balloon is ruptured. Means suppose the balloon, if you prick with the pin that balloon, the balloon will lose its all the air dramatically or dynamically, or you can say suddenly it will lose its air, and thus this is the one of the example of the free expansion. And one more example is the rupturing of the tire. So from this example you can see that the cyclic process and the free expansion. So one important thing about the free expansion is, students, the free expansion cannot be plotted over the PV diagram. Why? The reason of we cannot plotting it in on the PV diagram, just because this system is not in thermodynamic equilibrium. So we are just following the graph of PV diagram only those systems who will be obey the thermodynamic equilibrium, who will be in the thermodynamic equilibrium. Thus the free expansion is not the thermodynamic equilibrium phase, so we cannot plot it over the PV diagram. So this was all about which we have learned, students, in the cyclic and the free expansion process. Now next part we will see in the next lecture, next video. Thank you so much.